Okay, so before we go forward and talk about storing and retrieving XML, we really have to know how to parse XML, how to programmatically go in and take XML and break it down into programmatic structures, convert it, put it in a database, or bring it back out and aggregate objects and convert it back into XML. To do that, we have to know some parsing techniques, and there's really two been around for a long time, standard parsing techniques for parsing XML. Now, if you were a programmer and you were doing this, you could just read it in as a big string, right? That's XML is just a big string-oriented document and deal with it yourself. And there's some ad hoc libraries for doing so. And I mentioned some down at the bottom in Java, and there's other languages as well. You can find all kinds of different one-off ways to handle XML documents. But I'm not going to, that's not structured, if you will. That's kind of ad hoc. I'm going to talk about the two standard ways, DOM and SAX. There is something now called the Streaming API for XML, or STAX, for dealing with kind of streaming structures over XML. But in any event, it really never found full traction for a lot of use cases. So I'm going to leave that one. I'm going to stick with the basics. The basics is you should really know the difference between DOM-oriented parsing of an XML document and SAX-oriented parsing of an XML document. So let's talk about those two things. We saw before in other modules, I was drawing this tree structure, right? And in fact, we had a different looking tree in one of our other notes up above. The tree structure is referred as the document object model, and that W3C standard defines those seven different types of nodes we talked about before, and the common nodes ones, right? The document, the element, the text attribute. These are the common things we're looking for. Normally when you're parsing a document, we're not looking for the processing instruction and so forth. We're looking for where our root element is, what the text is in the content model of an element, what the attributes and the attribute values are for different things, and that's what forms that tree. So this tree doesn't, is visually represented a bit different than what we had up above, but you've seen one of these before. So our goal with DOM-oriented parsing, loads in the document and converts it in memory to this kind of structure and holds it in memory, and then you basically have a traversal API to traverse around and find the things that you want in the document, and that's what DOM parsing is about. The W3C defines an abstract API. What do you mean by an abstract API? An abstract API is language independent, all right? It is not bound to Java, it's not bound to C, it's not bound to Python. It's an abstract API that has different language bindings specified for it by different implementation folks. So for example, Xerxes was for a long time one that was used in the Apache open source community for its implementation of DOM. And actually the SAX parser in Xerxes would actually DOM something up and do SAX first, but that's not a relevant detail. That's not important. What is important is I could look at these interfaces defined in the abstract API and know that there was going to be a corresponding language-specific method that I could find in the language binding for it. Some interesting ones that you might want to call things like in the document, get elements by tag name. I could get all the elements with a specific tag value. I could get the child nodes of a particular node. I could get the node value. If that node's text, it would return the value of it. I could get the node name. I could get its attributes and so forth. All these kinds of getters as you might expect working with a tree-based API. And if I wanted to traverse, I could get the child nodes, get a node list, a list of node types, and then iterate through it and go get those nodes and get their child nodes. And I could do this kind of breadth-oriented traversal of the DOM tree if I wanted. All right, so we have some examples of that. I'm not going to walk through this. I did some code walkthrough videos that are posted on the class website, but this is kind of what it looks like. Refer to the code walkthrough for the person XML example and this code, and it'll walk you through exactly what goes on here. I am going to point out real quick some very simple things in here and then go to that one, but there's our Java-based implementation of get child nodes, right? You could get the length of a node. Here's the node list type. So there were very specific, right? And even though you'd find all this stuff in Java, but notice how the package name is org-w3c, all right, .dom. That is the Java binding of the W3C standard for the document object model API, all right? Okay, but again, refer to the code walkthrough to go through this example and others in detail. You'll see values that come out like this, meaning it's actually going to traverse the entire tree, including different types of nodes and the like. All right, so that's all DOM does. All right, the DOM basically, again, takes in the big textual string in the XML file, converts that string to a tree, puts that tree with these standard node types inside of memory, and then provides these methods and many others that allow you to traverse around a tree programmatically to output things that you might want. Sax works a bit differently. All right, Sax uses an event callback mechanism. Sax calls an event at the beginning of a tag. When it encounters something that it thinks is interesting, Sax calls that an event, and you write code that gets called back. All right, so instead of you writing a main program, I mean, you still write a main, but your main program here, this, when you go through the code walkthrough, this is very top-down, right? It's a top-down, it's a traversal program, like you've written in data structures when you traverse trees. Sax treats it a little bit differently. Sax is going to treat your code as something that the Sax processing framework over here is going to go through the DOM tree itself, and when it encounters things of interest, it's going to call back to your program over here. And it's going to use a well-defined callback that you defined for this kind of thing. And I'll talk about what those kinds of things are in a minute. All right, so it kind of inverts control. It's the framework, and you have to register callbacks and then determine what you want to do. Now, what are some of the interesting things or useful things about doing that? For one is, and the most important one's down here at the bottom, it's considered lightweight and stateless. Lightweight in that it's not required in Sax, some implementations do anyway, but it's not required in Sax that you create a DOM tree, meaning you don't have that overhead of converting to an entire tree structure, shoving it in memory, taking up all the memory resources. Further, it's stateless. So a tree is stateful. When we take and create this DOM tree, this is stateful, meaning when I'm traversing around it and bouncing around the tree and going and getting different things with that API I was talking about, state means I have it in memory. It's resident in memory, and I can do an operation like get. If I'm here in my parsing, that's my current node, if I call get child nodes, I get all these outgoing nodes, right, branched off of here. But if I call it down here in element state, then I only get this one back, meaning the return value of get child nodes is going to depend on the state, what my current node is and what's currently in the tree. Sax doesn't work like that. Sax does not store this tree. It simply comes across a tag, and every time it comes across that tag, it turns around and asks your program, hey, is this of interest to you? Do you want to do something with it? Okay, so it's a completely different programming model, if you will. What does that look like? Well, there's 4 primary interfaces that you can, if you choose to, implement if you are working with a Sax parser. One is the content handler. Processes document data the parser encounters during parsing and provides different callback mechanisms as part of its interfaces. So the content handler has certain methods that you would have to invoke. There's an error handling. What if there's a problem in the document? It doesn't validate, it doesn't structure, it doesn't give you something that you expect. Well, then you can implement the error handler interface, and there's a set of methods then that you would be obligated to implement. So if there's an error callback, the Sax framework knows where to call in your code. DTD handler, process DTD information, and of course I should say XML schema information as well. And then entity resolver, that's kind of not as common. Customized handling for external entities and redirection of external entities. Didn't really talk about the nature of what entities are in DTD, so again, these two aren't really that important. The two that are important with these primary interfaces are the content handler and the error handler. There is a default handler, that class that implements all 4 interfaces. So typically if you just extend default handler in your class, then automatically you have the union of all those. But you could decide to just implement content handler and error handler. That's actually what I usually do. Here's an example of some of the methods that are in here. So in a content handler, I'll get an event. I'll get a callback on start document. I'll get a callback on element, right? On processing instruction, on end element, on end document, all these things that you see here. And a few others, if you will. What that means is, look at start elements, very common. When we're processing a document and we come across an open tag, right? An open tag is a start element. It starts an element type of node, and therefore we implement start element and we get called back when the SACS parser encountered that going top down. And then there's going to be some stuff inside the tag, and then I'm going to have end tag to end the element. Well, that's the end of element. I'll get the corresponding call here, right? Now, if I wanted to remember all the things that were in here, right, as part of the content model, subtrees, textual content, I don't have that state automatically, meaning when I get to end element, I don't automatically have everything that I just went through from the opening start tag. All right, it's stateless. It means if I wanted to hang on to it because I needed to do something at the end of that element, right? Maybe I was reading in a student, I was reading in a person, right? One of these other XML examples we've seen before, I would have to hang on to that information in memory myself in my own data structure because maybe I want to turn around and write it to a relational database, or I want to do some computation on it or whatnot. Point is, I have to hang on to it. I don't have to hang on to it myself back here in a DOM, right? When I'm here, like this is the person example, I don't have to hang on to, let's say, the address, right? When I'm going through the address from beginning to end, I don't have to hang on to this entire subtree because it's already here in the DOM. When I'm here at city, or let's talk about a use case. Maybe I'm trying to implement a zip code verifier. I want to know that the zip code that somebody entered into that XML is valid compared to what they tell me about the street, city, and state that they're in, right? Or maybe it's city and state. Well, when I get to this node and I know it's a zip code and I look at this text, I can write a verification routine that says, yes, I know that's Mansfield, Massachusetts, and that corresponds to that zip code. I can do that just by navigating over to sibling nodes in this DOM. What I'm saying is in SACS, I can't do that. All right, in SACS over here, when I get to that part, I can't navigate to it because it's not in memory by default. I would have to create that state myself, all right? That's what stateless programming is. That's what makes it lighter weight because I'm not hanging on to all this stuff in memory, and I don't have to parse all the way through it. I'm doing it on the fly. But the drawback is if I want to do something stateful, doing it in a stateless model can actually be very tricky and careful programming that you have to do. So that's a content handler. The error handler, I said, the other one that you commonly implement for good, robust parsing. You'd be indicated if there's a warning, an error, or a fatal error. So there are warnings and errors, but then there's fatal errors, meaning the parsing is going to stop. And of course, you would want to know that. Sometimes you may discard warnings. Other errors you certainly want to handle. But the error handling callback, you would want to deal with. So what I would do, and again, I have a code walkthrough for the SACS parsing examples as well that goes alongside the DOM one, but you would create a handler class yourself that implements the content handler and error handler, meaning I might have my class, my parser implements content handler, I'm not writing it out of course, error handler, or I could have class my parser extends default handler, and actually this probably extends. I might have to look that up actually, know whether it's an extends or an implements, because usually what you get with default handler, for example, are empty implementations of the handler methods, meaning you would see that you would actually have to override them in order to customize the methods that you would want to use. So for example, you may not care about processing instruction as a callback. Very often you don't. There's a default empty implementation of that, which means when SACS calls back on your processing instruction up here, the thing with the question mark, it'll execute a callback, but you just inherited an empty one from the content handler class or from the default handler. So you only override the ones that you want to do, which very often are start element and end element. Those are the first ones. Sometimes start document and end document in order to do the processing you want to do. And again, depending on the class of errors that you want to deal with, same thing with error handler. All right. The rest of this I'm going to leave to the code walkthrough. Then I'll go in detail how you create that SACS parser and how you write some of these callback methods. All right.